Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to this ongoing online course on Engineering or Architectural Graphics Part 2, where in this course we have been discussing about how to draw isometric projections and now axonometric projections for the given objects 2D or 3D. In the first 3 weeks, we have seen how to draw isometric projections, and in this week, which is the last week of this course, we have been discussing about the axonometric projections. So, what we have done so far is we have seen how to draw axonometric projections of two-dimensional objects, the planar objects, and then we saw for simple solids, the rectilinear solids. So, in today's lecture, we are going to see how to draw axonometric projections of cylinders, cones and spheres, basically the curved surfaces. We have already seen the axonometric projection, how to draw that for circles already, and now we are going to look at the same thing, but in 3D cylinders, cones and spheres. So, let us start by taking the examples as we have been doing in this case, and what I expect you to do throughout this course, this is what I have expected and also communicated, is that while I draw here on my screen, I want you to draw in your sheets, on your sheets with the help of proper stationery, with the help of set squares, rulers, drafters or T-pulleys or whatever you have to use, so that you are practicing simultaneously. Okay, so we have a cylinder. Now, with the help of this orthographic projection, the drawing which is given, we can very clearly see that it is a cylinder which is kept in HP and the axis is perpendicular to HP and parallel to VP. A very simple position, which is what we are going to draw. So, I can start from the top, or I could start from the bottom, but what I am going to do is start from the top, which is where I am seeing this shape which I am seeing in the plan here. So, what we are going to see is that this is a square which is going to be tilted by 45 degrees. Just for my reference, I am making these two axes. This is the square which is going to contain the circle, and as we already know that the circle in axonometric will remain to look like a circle, will remain a circle if the plane is parallel to HP. So, we will get a circle here. This is what we get in the top. And now, very clearly we know there are two things, and of course, partly we will have to draw. You bring the surrounding cuboid down and we get the same plane here, which is where our circle is going to come, the circular plane in the base of the cylinder. And just as we did in isometric projections, we will be drawing tangents. So, we know this is where the tangent to the circle is going to come, this is where it is going to come. And very simply I can now darken what we will be seeing as an axonometric view of the circular cylinder which is straight. This is what we will see. Now, if you remember what we saw in isometric projection versus what we are seeing in axonometric projection, isometric projections, they look more realistic. So, this circle, if it was drawn in isometric, we would have seen an ellipse slightly stretched and it looked much more realistic. However, it is much easier to draw a circular cylinder like this, a very simple position in axonometric, because all that we have to draw is a circle, drop the tangents equal to the height of the cylinder here and draw the bottom base of the cylinder, and then we are done with the axonometric. Now, if this same cylinder is kept in such a way that it's having its axis parallel to HP and perpendicular to VP. So, we know very clearly what we are going to do. I am again starting from drawing the base. You could start from drawing the elevation also, but as I said that it is much easier to start axonometrics by drawing the base, and which is what I am going to do here. So, I will just make my axis here for the reference. I am just reminding you that the axis in axonometric is at 45 each. So, now I am drawing the base of this, which is the plan which I am going to see here in orthographic to be drawn in axonometric. This is what the plan of this one is. We have an axis which is going here, which is what we also see in the plan. This is here. And we know that there are the elevations which we are going to take for these. Now, I am only going to draw elevations and then we will generate the curve out of that. So, look at this one here. So, we have 0 elevation for this point. For this one, you do not have to do it, you can directly take, but since I do not have a grid here, I am just drawing myself some references. Okay. So, another point above this is at a distance which is equal to the diameter of the circle, the circular base, and at the mid height we have this point raised to this height, which is what we are seeing here. So, this is the height which I am taking on both these levels. So, this is what it is, and just like we drew other times, we will complete drawing the circle here. The process remains the same as we did for axonometric. This is what we get here. The same thing you can get at the back. We do not need to draw it full. So, the portion which is going to be visible is this. I am just drawing this for the reference, but you may decide, you may choose not to draw that, and then I am going to join the tangents. In curves, whenever we are drawing curved objects 2D or 3D, we are going to be taking the tangents. This is what we will see. So, in axonometric, where this circle, the curve is in a plane other than parallel to HP, we will see it looking slightly skewed and not a regular circle. So, this is what we will see as a circular cylinder which is perpendicular to VP and parallel to HP. This is what we are seeing, this is what we will see as hidden, this is not going to be visible. So, very simply we started with drawing the base of it, raised the height to all the points which were given, and then arrived at the curve. This is the exact process that you must follow when we are drawing the axonometric. Now, right now you might be thinking that why can't I start by drawing the elevations first, but we are going to be using axonometrics mostly for drawing the architectural views, and where the architectural plans have already been drawn, and it is much easier to just rotate the plan by 45 degrees and raise the heights, whatever heights you have taken for different building components, and arrive at a view, a 3D projection. That is what the purpose of axonometric is, and through these smaller exercises we are just trying to practice the same methodology and trying to arrive at the axonometric projection. Let us look at another slightly more complicated one. Now, here this cylinder has its axis parallel to HP and inclined to VP. Okay. So, this is what we are going to draw here. Now, I will again start by drawing your plan here. The same process, this is the axis here at 45. Now, I have to draw this plan. Look at this, there is a straight line here. Okay. So, I am just trying to take a reference, we can directly draw it because we know this angle 30, we can add 45 degrees. Now, I do not have a reference here. So, what I am going to do is I am going to draw a reference rectangle and then take it on the axonometric. So, something like this is where our rectangle is coming. So, this is the rectangle. Now, there is slight error because this angle is 90 degree and we have to retain that. It will be retained if we just incline it. So, I would rather approximately this is what we are going to get, a rectangle which was inclined. So, something like this 30 plus 45, it will be around 75. This is looking more or less like 90, but it has to have certain angle. This is what we will see as the plan, and now we will give the height to it. So, now you can see that there are these markings on the side. So, we will have to mark the same ones here, which is what we will have. This is the axis. Okay. This is what we have, and now we have to give the height to all these 12 points which have been taken here. So, you can just raise it. So, all we have to do is, okay, in fact, I think I should slightly incline it more, or maybe I will try to draw it here. We will just give it the height that each point has. So, you can simply make the grid. I am drawing perpendiculars here, just like we see here. This is what I am doing by taking the heights of all the points and then joining them using French curves to get the axonometric projection of this circular base of the cylinder. Exactly the same thing we will do with these 12 points. We will raise them vertically at the heights which have to be measured from here. This is what approximately we are going to get at the back too. And you will see that the fundamentals, the basics of axonometric hold good here. These two circles will come out to be parallel to each other, and now all we have to do is join them with the tangents. This is what we are going to get when we draw a cylinder which is inclined to VP at a certain angle. Now, it depends upon the angle. So, approximately this, you will get a more accurate shape because you will be drawing using proper stationery. I am doing it freehand, but just follow the process and you will get something like this. Slightly tilted, it will be slightly more tilted than this. Okay. So, you can draw any number of examples using this. This is the other way around, where the cylinder is inclined to HP, but has its axis parallel to VP, which is where we see. So, we have an angle given, and we will but we will start by drawing the base first. That is the process that we are going to follow. So, you start by drawing the base first very simply, and then take it to the above plane, take it to the vertical plane, give different heights to each one of this. So, we will start by drawing this shape in the plan and then taking the heights. I am leaving this one out for you, but I wish that you will all try this at home, and in case you face any problem, you can come back to us and we will solve the query. This one is doubly inclined. Now, here we can see that how this one is going to come, where it is both doubly inclined, and we are not going to draw the faces separately and the rest of the body separately. All I am going to do is draw the plan and then take the vertical projections of each of these points and arrive at the projection. So, now what we will do is we will draw the exact shape and incline it by 45 degrees. Now, if you look at this, this is already inclined at 45 degree, and if I further incline it at 45 degree, we will see this same shape coming at like a straight solid. It's a straight shape. So, 45 plus 45, and I am inclining it like in this direction. So, what we will see here is as if the orthographic view of this a cylinder which is inclined to HP and parallel to VP. This is what we are going to be seeing. So, the same object I have inclined and I have drawn here, but remember that our axis is this. You do not have to forget that. Okay. Now, there are 12 points, which is what we will get from here. So, we will get all the 12 points here. So, whichever way they have been divided, if it is a grid or angular, whichever way they have been divided, we will take the same 12 points. So, exactly the same thing we got back here. Okay. Right. So, 12 points here, and now we will draw their respective heights. We will take the respective heights, whatever we are getting in this elevation. So, now look at this. So, there is this point in the bottom. Okay. So, this is where it is. If you look at this point here has a height of 0, and this point, which is actually the point just opposite to this, which is this point here, is the point which is going to be at the highest. So, we provided certain height, whatever that height is. Okay. And now, you can see that this axis, which is what we are seeing here, is what we will get here, right. And now, there is this point which is at this height here. So, there is a point in between which is at a certain height here, and right opposite to that there is this point which has an equal height. So, we raise this again. So, if I have to draw in axonometric, we will get an ellipse something like this. Now, I am right now drawing only 4 points. You will have to arrive at all the 12 points and you will get a smooth ellipse. This is what we will get here. Now, right now I am not darkening it because this is this is the bottommost point and this is the topmost point and this is what the ellipse would look like. And now exactly the same thing we will draw with this one. So, if corresponding to this point which was here, we have an opposite point which is G, which is coming somewhere here. So, we will take the projection of this point opposite to this, raise. Opposite to this is the point which we will raise further. So, parallel to what we get here, there will be an axis which will be coming. So, we will get these points here and we will get the rest of the points . And we will get a parallel ellipse here too. This is how we are going to get, and then we will just join the tangents of both these ellipses and we will darken the part which we will be seeing in the front. This is the axonometric view of a cylinder which is doubly inclined. This is what we are going to see. Now, you might not be able to decipher exactly that how this one is, because this is a free object. This is not in combination with other solids and you cannot really place that along with this axis how is it really being perceived. But if I could draw a screen for you at the back like this. So, assume that there is a screen at the back and then you will see that there is an axis which is coming. You can identify the axis and you can see how the angle of this cylinder is coming. So, it is inclined to both HP and VP, which is what we will actually see in this. So, the methodology remains very clear and simple, that we have to draw the plan first and then take the heights for all the points which have been marked on the plan. In case of curved surfaces, in case of curved solids, we have to mark all these 12 points and those points, the heights of those points in elevation respectively have to be known and also marked. That is a very simple exercise. The only difficulty often which you will face is that you will get confused as to where these points are. So, I would suggest that you always mark just like they have done A, B, C, D or whichever way. So, 1, 2, 3, 4 or A, B, C, D. So, this is exactly the same thing which you should be doing here. So, if it is A, B, C, D, you must mark, or 1, 2, 3, 4 whatever helps you in identifying what are the points that we are taking. And the same thing you will do here. So, right now you can see that there are only certain lines which have been taken, but ideally you would be drawing all of them. So, all of them will be drawn and you will be taking the heights for each of the points without missing anyone and then draw them properly. That is what we will always be doing in axonometric projections. Let us look at another solid which is this cone. Again very simple. Now, here we will have to draw the base first, because very simply base is what we are going to be seeing when looking at it from the top as a flat thing. So, I am drawing this axis. We get a simple circle. So, you can simply identify the center and use the same radius to draw this. circle. Now, the only point which has certain height is this apex O, which is here. You raise it vertically, mark the height at which it is coming, and then draw the tangents. That is what we are going to do simply, and that is what the cone will look like. It is much easier to draw, but then it looks little less realistic in comparison with ISO, but it is much faster to draw our plans when we are doing the architectural plans or even the engineering drawings using Axono. So, this is a simple cone which is kept. Now, if I draw the axis here, you would be able to make a sense of it, how this cone is kept. This cone is simply kept perpendicular to HP such that its axis is perpendicular to HP and parallel to VP. Now, what if this cone is kept in such a way that its axis is perpendicular to the VP? So, what we are going to be doing, I am going to start by drawing the plan first, whatever is being seen in the plan. I am not deviating from that, and we will keep that methodology as the same. So, what we have here is we have a triangle like this. This is now at 45 degrees, an axis perpendicular to this. Whatever length it has, we cut it, and this is what we see in the plan. This is what it is. Now, what we have here is, right now I am only taking these 4 points of the circle. These two, this point is in the ground as well as it has the height equal to say diameter here, and then we raise the heights for the other 2 points at half the diameter here, these 2 points. Join these to arrive at an ellipse. We could start by drawing more number of points, 12, but 4 is also enough in this case. Now, this has a height equal to half the diameter. So, this is the point where we will have the apex, and now we will join the apex with the draw tangents from apex to the base. It looks slightly odd, but this is how you will be seeing the axonometric of this cone when it is perpendicular to VP and it has its axis parallel to HP. And you can also draw the axis of this cone. So, however skewed it might look, but if I draw the reference plane here, this is the reference plane, you can make a better sense of how this object is placed. So, you can very clearly perceive that this is placed perpendicular to the vertical plane. So, this axis is parallel to HP, but perpendicular to VP. Similar way, you can draw any position in which the solid has been kept, and given whatever orthographic, the final orthographic projections, you can very simply convert it. So, here this is I think 45 degrees. So, I will just draw the initial drawing for you, and after that you have to complete it. This is the axis that we are looking at. Now, if this is 45 and if I rotate it in this direction 45, what I am going to get is apparently a cone which appears to be parallel to this axis, which is again going to be further inclined at 45. So, this is what we are going to see. I am just drawing a reference rectangle here, which is say this. So, what we will have here is, so this is the apex. So, this plan will look something like this, where the axis will look parallel to the sheet, but not to the reference axis. So, this is what we will see in the plan, and you can draw the same number of points here. So, here, which is what I will just draw these lines here for your clarity, which is exactly what we are seeing here. So, now we have drawn the plan. Now, we have to give the height. So, this O, which is the apex, is at a certain height, which is what say this is. So, this is O, and for all these points you could give a nomenclature. Here D, let us assume that this is kept in ground. So, D remains here, but another point right above D will have its height something like this. Now, you must remember that this is originally, if this was 45 and we further incline it 45, this is how it is going to look, and all the points are going to be in the same line. So, what you will actually see is a straight line here in the axonometric like this. So, it is actually all the 12 points in the same straight line. This is the apex, and all we are going to see in axonometric for this particular cone, which is inclined at 45, is this. This is going to be the final view of the cone, which is inclined at 45 degrees to VP. Now, I will again draw the reference plane, and you may try to perceive this cone is actually in 3D, but when we are looking at it, it is already inclined at 45 degree, and when we are looking at it, this is how it is going to appear. I will show you couple of more examples, but I will not draw here. I would request you to kindly draw them at home following the simple procedure. Draw the plan first, give the heights to each of the points, whatever you are seeing, and then you will get at the final object. Okay. So, try drawing this cone, which is resting on one of its generators in the HP, and the dimensions you can assume here. So, try drawing this cone. Now, the last one that I am going to draw here is this axonometric, and I am going to draw the basic sphere for you first here. I will draw, and the process of drawing the sphere remains the same, and I am going to do the same thing as we did for ISO. Okay. Assuming this is a freestanding sphere here. So, this is the total diameter of the sphere, this is the total height of the length of the diameter here. Now, if we are seeing this sphere, what you will see is a circle here, right. So, this will actually be seen if we cut it. So, hemispherically in this plane, this is the sphere that we will see. In this plane, if you see, this is where the center is, this is where this point comes on the top, this is what we see, and not here, but actually here. So, this is where we will see. Sorry, I should erase this, this is confusing us. So, this is where we are going to be seeing the sphere coming like this, if we are cutting it vertically, And the similar thing happens if I have to cut it in this plane at the center. So, you raise it further up, this is where you are going to be seeing the Now, if you look at this, this remains the center of the sphere, and what we will see here is that the maximum distance that you are going to get for this sphere is this distance here. So, if you keep the center at this and take the maximum here, this is how you are going to get the touching all the outsides, this is how you are going to see the sphere, and which will, right now it is not appearing so because my scale is slightly disturbed, but taking the same center and a radius which is more than, apparently in axonometric the sphere will be seen as bigger, which is how we were seeing it in isometric also. So, we will see it slightly bigger and it will be touching the outsides of all the curves which we have drawn in the 3 planes, and it will be an exact circle. So, which is exactly the same process we followed in isometric, which is what we will get in axonometric too. Okay. So, the only thing being that we can't directly derive the radius. In isometric we were using the isometric scale. So, if we were using the isometric scale, the true dimension of the sphere was what was seen in isometric view if we were using isometric scale, or it was scale up to 1.2 times. The same would happen here in axonometric scale, and we will see a bigger circle representing the sphere. Okay. So, that is what we are going to see in axonometric too, and I will stop here at this, where we have discussed about all the curved solids, cylinders, cones and spheres. So, this is where we are going to stop, and we have one more lecture of this course of this last week, where we will look at some more objects, combination of solids, how to draw them in axonometric. So, thank you very much for joining me today. See you again for the last lecture tomorrow. Bye bye. Have a great day.